The Lac Creek field, the Lac field rather, is a major natural gas field located in the French foothills of the Pyrenees Mountains and structurally similar to the Strachan sour gas field near Rocky Mountain House in the Alberta foothills. In 1951, after 10 years of just natural gas production, a series of earthquakes occurred greater than magnitude 4 events. These induced earthquakes have been studied extensively with results published by French and other seismologists. The largest and most catastrophic oil patch earthquakes that we know about occurred between 76 and 84 with a series of magnitude 7 events. This was the result of production from the giant Gazli natural gas field in Uzbekistan with initial reserves of 17 trillion cubic feet, a truly giant field. Russian seismologists were completely surprised by these earthquakes as they occurred under a natural gas field located on a tectonically stable plateau. However, later investigations revealed Gazli was actually a faulted anticline with buried faults not visible at the surface. Official reports revealed considerable surface damage and hundreds of people were injured with only one fatality. Anecdotal information indicated thousands were killed and that this tragic earthquake was covered up by Soviet officials of that time. This slide illustrates a very unique example of human-induced earthquakes which occurred during the first Gulf War when Iraq was blowing up oil fields in Kuwait. Note the Burgan oil field, which is the second largest conventional oil field in the world. Only the Ghawar oil field in Saudi Arabia is bigger than Burgan. As an aside, to think the tar sands of northern Alberta is the second largest oil field in the world rather than Burgan is very misleading. The magnitude 4.7 earthquakes on this map were documented in 1993 and published west of the Burgan oil field. These earthquakes coincided with Saddam Hussein's invasion of Kuwait about the control of disputed oil fields. It's likely that as a result of these oil field explosions, sudden changes in the subsurface pressure regime caused movement along faults in the area, triggering these induced human earthquakes. New Haven natural gas storage site. In order to help predict seismicity and mitigate possible earthquakes in subsurface storage projects, it's necessary to conduct seismic baseline monitoring surveys prior to the injection of natural gas, or CO2. The second step is to implement permanent seismic monitoring as shown in this slide. This is a schematic of the New Haven natural gas storage site in Michigan, designed for ongoing seismic monitoring over an experimental shallow reservoir. Remember, once local seismicity starts on the Peace River Arch or anywhere else, it cannot be turned off. The original purposes of this experimental storage project were: 1, to determine reservoir vulnerability to escaping gas due to induced seismicity and fracturing, and 2, to determine potential liability issues as a result of reservoir leakage problems. The Alberta Research Council is just now reviewing plans to conduct seismic monitoring on this proposed CO2 storage project in the depleted Redwater oil field. For similar reasons, effective baseline seismic monitoring of natural seismicity must be employed to mitigate risks of future accidents at the proposed nuclear power plant location near Weberville. These are my conclusions to my 1995 talks on oil and natural gas-induced seismicity, or human-induced earthquakes, with more slides to follow after this slide. Induced earthquakes are real and can be fatal. Engineering seismic studies generally deny induced earthquake risk, often claiming the event was going to happen anyway. Improved collaboration between petroleum geology, geophysics, seismology, and engineering could improve induced earthquake prediction and mitigation. Given the right conditions, earthquakes can significantly alter oil, natural gas, water flow, and the containment of stored CO2. Mitigation and responsibility issues can be addressed by on-site ground and borehole seismic monitoring. The next section of my talk is the connection between geology and energy supply, induced earthquake hazards on the Peace River Arch, and the crisis of global climate change. This slide is the original curve published by David Keeling based on his detailed measurements of CO2 in the atmosphere on top of Mauna Loa. In 1903, Svante Arrhenius, a Swedish scientist, received the Nobel Prize in Chemistry. He is acknowledged by mainstream science as the first to prove that changes in CO2 measured in the atmosphere is the driving mechanism of global temperature change. This was established during the previous 650,000 years during the Pleistocene glacial and interglacial episodes. This has been conclusively proven by mainstream science through the study of CO2 bubbles trapped in Antarctic ice cores. Now, there are many global warming deniers who still believe changes in atmospheric CO2 are not the dominant reason causing changes in global temperature. We say to them, prove Arrhenius is wrong and win a $50,000 Nobel Prize in science. This is an historic photo from the Columbia ice fields and illustrates how glaciers melt at the base. This melting weakens and causes fractures in overlying ice, causing large blocks to collapse and fall. A similar melting process is on much larger scales occurs in other glaciers around the world and on Greenland and Antarctica, which I'm sure many of you have seen in video shows and movies. This is an old photo of the Athabasca Glacier, which shows the foot of that glacier at the site of the Banff-Jasper Highway, which had not yet been built. This photo of the Athabasca Glacier was taken 50 years ago from a similar position as the previous slide. This illustrates a retreat of the Athabasca Glacier at a significant distance from the Banff-Jasper. The Athabasca Glacier has since melted much farther upslope. The headwaters of the Athabasca River system begins at the top of this Athabasca Glacier and runs through much of northern Alberta, past Fort McMurray, flowing into Lake Athabasca before emptying into the Arctic Ocean. As a result of land-based glaciers melting in many other parts of the world, global sea level is steadily rising. This is a photo of Bimini, a small island in the Bahamas, looking to the west, with Miami 50 miles away on the horizon. One realistic estimate is sea level will rise 2 meters by 2100. When this happens, most of Bimini will have disappeared. At the same time, many coastal areas of southern Florida will also be permanently underwater. This photo was taken in 1960, a few days before Hurricane Donna smashed into the Florida Keys. More of these highly destructive hurricanes along the Gulf Coast are occurring as a result of global warming and climate change.